Most days on orbit, crew members also spend time looking out the window. Often they take pictures of what they're looking at. There are other cameras on the outside of the station that are doing some of the same thing. It's no secret that the views of Earth from space are pretty spectacular. In fact, there are 4 new cameras on board the station that are giving the most unique views that we've ever seen. Let's go join Lori Meggs at the Payload Operations Integration Center at NASA's Marshall Space Flight Center in Huntsville, Alabama, to learn more about the high-definition Earth viewing experiment.
To date, there have been more than 22 million views of the high-definition Earth viewing cameras. Those are 4 cameras that are attached to the outside of the space station that stream live video of Earth back and for use online. And they're looking at how they react in the harsh environment of space. An analysis of that data could lead to what types of cameras are the best to use on future space missions. We spoke with the Associate Program Scientist for Crew Earth Observations, Will Stefanoff, and he tells us more.
Yeah, the HDEV is currently capturing a lot of web traffic because it's a first for a number of reasons. It's the first continuous HD downlink from the ISS. I mean, we've had other cameras up there before, but they have sort of been spotty coverage. This is the first one that's on all the time. It's actually 4 cameras, 4 commercial off-the-shelf HD cameras in an enclosure that's built to test temperature control. And the cameras, the main purpose of the HDEV project is not to take Earth imagery. That's just a very cool added bonus of it. The real purpose is to test how long these cameras can survive in the space environment before they degrade so much through things like cosmic ray hits that they're not usable anymore. So with the 4 cameras, there's one pointed in the RAM direction, the forward velocity vector of the ISS. There's 2 facing aft and 1 facing nadir, looking right down on the Earth. And the way the system is currently set up right now, the video feeds cycle through all 4 cameras. But there's 2 educational opportunities that are coming up that we're working with student groups in Germany, University of Bonn, through the German Space Agency, DLR, and also the University of Houston Clear Lake has a group of students also that will be looking at the camera both to collect data for specific areas, but also to monitor the primary purpose of the experiment, see how the cameras are degrading over time. And so those programs are just getting spun up. But in the meantime, yeah, the HDEV is returning spectacular HD views of the Earth. Other firsts for it, it's the first payload that was completely robotically removed from the SpaceX spacecraft and installed on the ISS. It's the first one to use 4 cameras simultaneously, 4 commercial off-the-shelf cameras. And it's also useful for showing not only just views of the Earth, but also when the feed cuts out, just because there are times when the ISS can't transmit data to the Earth, that gives the person viewing it kind of a sense of what it's like to actually work with the ISS. There are points in time where neither the sensors nor the crew can actually talk to the Earth. Fortunately, those periods are fairly short, but by viewing the HDEV feed, you kind of see exactly what that periodicity is.
Yeah, it's kind of a first to have this much excitement about just looking at the Earth too,
Yeah.
by folks around the world with social media and
Yep.
things like that. It's really made this explode, I'm sure.
Yeah, well, it's a new view of the Earth. I mean the crew photography, you've had that kind of detail before, but it's still imagery. I mean we also have the time-lapse imagery that's been developed from camera sequences, which also provides a really spectacular view of what it's actually like to look out the window at the ISS. But the HD camera, yeah, is capturing it kind of in real time. So it is really like you're on the ISS looking out the window.
Are you surprised by how much people are excited about this and want to see it?
Not so much. I'm not that surprised because just from the Crew Earth Observations Facility, we've kind of always known that people are just really excited and interested to see views of the Earth from space, and to know that there's this human connection. This is a view that's not coming from a robotic satellite. It's actually coming from a spaceship that has people on it. I think that resonates with people. That gets a deeper connection than just say looking at a Landsat image, or another sensor image. It's very easy to interpret. It's a true color image. It's basically what you'd see flying out of an airplane. Just it's a very high airplane.
A little bit higher.
Yeah.
So what will we see next? I know you've probably got to stay one step ahead with technology and Earth observations. What's next?
Well, we have right now we have 2 sensors which are going up on ISS this year. One is the CATS, Cloud Atmospheric Profiling LiDAR system. So it's a laser system which is going to be looking at particulates in the atmosphere and also being used to look at storm circulation patterns. And then there's also the RapidScat sensor, which is a radar sensor. And what that's going to be looking at are sea surface wind patterns. And both of those tie into how Earth's climate is changing over time with rising temperatures, how circulation patterns are changing. And then we'll also have, further down the line, we have other sensors coming online which will look at other elements of the atmosphere. Sensors which will look at the solar input into the system, sensors specifically designed to look at solar irradiance. Those are coming down the line. There's also more hyperspectral instruments coming down the line, so that we'll be able to get more detailed information about land surface processes than we currently have from sensors on the ISS.
And that's been useful. HICO has been extremely useful
yes.
to the EPA and everyone, right?
Yep, the EPA's used it. There's a wide variety of scientists around the world who are using it for research. It's been useful for water contaminant studies. It's useful for mapping shallow water bathymetry. And people are actually starting to use it now to look at the land surface as well. And it was specifically designed to look at coastal areas, but it can also collect useful data over the land too. So we have a number, in fact, just this morning, CASIS informed us of 3 new proposals that were accepted, which will be using HICO data to look at both water and land processes. I'm just glad to see the ISS sort of coming into its own as a remote sensing platform. I mean, I've worked for years as a researcher with the more traditional kind of robotic satellite sensors, and those are well designed for the data they collect, but the ISS allows us to collect, in some ways, a fundamentally different kind of data because it goes over different spots of the Earth at different times during the day. So it allows us to view things that we haven't really seen before from a remote sensing perspective. And that's really exciting as a scientist and somebody who's now has the privilege of kind of helping to develop the ISS.
You've seen some of those views from the high-definition Earth viewing experiment before. That's operating all of the time. As Will Stefanoff explained, that's 4 high-definition video cameras looking forward and straight down and aft as the station orbits, providing some really nice views of the Earth as it tests out how well the cameras themselves work. The primary goal of the experiment to make sure that those things are working. You can get a look at the video that's coming from those cameras by checking out the web address here, eol.jsc.nasa.gov/HDEV.